I will be working on Macbook a1708 and the board number is 820000840. What is happening here is not turning on. Not turning on. What we usually do is to get an ammeter, plug in here, not drawing 20 volt, and even the amps are very low, so it's not gonna turn on. So what comes to our mind quickly after watching lots of videos, that this must be Type C power management IC, something wrong with it. But before you even come to that conclusion, you also have to look at if this Type C DC jack is even delivering any power to Type C units. If it's not, then we're gonna get the same reading, 4.5 or 5 volt. Why would I say so? Because first of all, if you look here, that is pin number 4 from here, 1 2 3 4. See, I can't call it burn, but see, this is how it is. And same thing happened here, and if you look back, number 4, same thing happened here, same thing happened here. So so just by looking at these physical evidence, I come to the conclusion maybe there is something wrong with these Type C DC ports. So I have to verify it. So I will show you here. This is the board here, and what I would like to verify is, let's take for example this one. So if the Type C charger is plugged in, that means we should get 20 volt here before it goes to, see, before it goes to Type C power ICs, which is U3100 and U3200, right? So let's come back here and is it on? Okay, let me check if it's on or it's not on. Oh yeah, so this is on, as you can see, but we have to check the capacitor, which is C3308, if we are getting 20 volt here or not. Let's check if the multimeter is on the screen. I have to turn it on so that we can read it. Yes, it's on now. So this is what we were looking on the diagram. If we are getting 20 volt here direct from, whereas, do you see, haha, 4.9. 4.9. Okay, so and these all capacitors, they are in one line where it should read 20, but they are not. So my conclusion here is, even before, it's like we check any laptop DC jack, if you are not getting right volt on the terminals, then most probably it's the DC jack, but I don't know, this is what I'm assuming. It looks like those pin number 5s on the DC jack is damaged from the both side, that first of all I have to replace the DC jack, and then even then if we are reading 5 volt on the amp meter and if it's not turning on, that is where we have to look at type C power ICs, which is U3100 and U3200. But first of all we're gonna remove this DC jack and solder new one on. What I have to do first is to remove this metal shield, but before that I would like to save this gasket so that I can use it on the newer DC jack. This is just to stop any moisture and dust to go onto the board. Okay. We'll just put this metal plate underneath. I don't want to burn the table. Okay. Oh, where the microscope is going. See, it's like sliding. Oh yeah, maybe I have to tighten it from here. Okay. Right. So I'm just gonna hold it like this, and then it should just use its gravity force and fell down.
It's because it's got some decent like rain and just
Okay, that's off.
so as I see,
Once this is done, let's check it one more time. Check what? You know, check what? So see, now we have do not have this metal plate underneath, and these DC jack connectors are exposed, right? What we can check from here, even at this stage, before we replace this DC jack, is here. Come on, man. See, that is what we were looking at before. So our board orientation is like this. So this is pin number, does it say ground? Anyway, so ground here anyway. So we can check pin number 19, pin number 37, pin number 22, 23. They are all on PP 20 volt USB-C, right? So honestly speaking, there can be something which is again in the same circuit or circuit which is connected to this circuit that is causing not getting 20 volt here, but this is what we have to do. Let's check pin 19 and 37 if we have got 20 volt there or not. So
How you going?
let's come back here and let's go under the microscope. So DC jack is in, and can you read the multimeter on the screen? Yeah, that's all good. Okay, let's check here. So this is most probably, let me have a look again. So which one is 19 and 37? 19 and 37. Oh, come on, man. So this is pin number 19. What we have here? Do you see? Nothing. Okay, let's go pin number. This is here. Which one is here? See? Nothing. So it gives me a strong evidence that first thing I have to do now to fix this board is to replace the DC jack. Let's do it. So now we will remove this DC jack. Hoping that this is what the problem is. Not actually hoping, but since we are working on some evidences, which is we see these connectors are sort of scratched or broken, and we are not jumping to the conclusion that it is U3100 and U3200. I don't think so. Oh yeah, that came out. And why it's not coming out? Come on baby, come on, come on. Now it's your turn. Wow, that's pretty strong. Okay. Let's give it a quick clean. I want this completely clean. This MacBook's thermal mass is very high, so heat just dispensed off. And there is another thing which I think I should do. I should cut this braid little bit smaller, because what is happening here as well, that it's just not the thermal mass of the board, it's also the whole length of this. Do you see it's getting little bit more hotter because the heat is also dispensing to the solder braid whole roll, whereas now I'm just stopping it here because I cut it short. So this will be a little bit a work of patience. So I will move it forward quickly. cleaning. This is what it looks like. And where is the new DC? Check. It's here. Okay. Right. So let's just have a look under the microscope. If this all looks okay, a little bit of, I will clean it. Right, let's do a little bit more cleaning. Oh, you can't see. You can see now. So, which way are the pins goes? Now, this we will set it up. This goes this way. So, I'm just trying to. Looks like yeah, it's sitting right. I can feel it now. The next thing I will be doing here is this, instead of holding it down, I will be using this one here. It's reversed user, as you can see. Okay, so now looks at the back side of it. Now what I want, okay, show you in microscope here. Okay, do you see? You can actually see the each pin. So I'm just making sure, because what I'm gonna do, it's all there. You can see, right? Yeah, okay. Now, just here. Now the strategy is, I'm gonna melt. Can you see clearly? Okay. I'm gonna melt low melt solder from here, that once it's melted it will go down to the other side. Okay, let's do it. Let's start from this side. Yeah, David, thank you. So David just got me a drink. Very nice of him. Now get back to the work. Okay. So I have to make sure I keep it here for a while so that it melts down, because if it's just staying on the top, then it's not gonna connect properly. So we will move to this side now. I need more flux here, so I'm just making sure it melts down. Okay, we will move our reverse user. I'm quite sure it's melting down. The reason behind is the amount of solder I'm putting. It's not as much staying on the top. That means it's flowing down. Let's clean it. Okay, that looks okay to me. Now we will connect the charger. And we know, I will show you one more here. So now pin number 19 and 37 we should get 20 volt. Let's see if we are getting any 20 volt there. Where are we? Here. Okay. So this is to here. And this is to pin number 19, which is this one here. Okay, do you see? So we have got 20 watt here, and we should also have 20 watt here, which we do. Okay. So that means now we have restored that line. That was DC jog problem. So anyway, thank you very much for watching. See you in next video. Thank you. Bye.